In this video, I'm going to summarize the strategies that we've seen for working with SD and introduce one more that we haven't really talked about yet. So, first one is alternate between working top down and bottom up. This is the most important strategy in SD. I mean, this is what's really core to working with the system. So, when you're working top down, you're deriving inferences from lines at the top of your derivation. You don't do very much of this. Most of what you do when you're working with SD is working bottom up. So you're looking at your goal sentence and you're determining what you would need to do to be able to derive that. Um, you figure that out. That introduces new goal sentences. So then you go and you figure out what you would need to derive those goal sentences. And your overall aim is to join up the top and bottom of your derivation. The second strategy is to figure out when you need to make assumptions. So, whenever you make an assumption, the cardinal rule is make sure you know how you're going to discharge it, how you're going to end the subderivation that you introduced and return to your main derivation to reach your overall goal. You don't want to make assumptions blindly so that you end up getting stuck in subderivations so that what you've derived is trapped behind an additional scope line and you can't actually use it in your main derivation. There are particular rules that you should use or at least consider depending on the structure of your goal sentence. We've gone through these in detail in a previous video, and I'm not going to go through them again here. Another strategy is to figure out how you're going to find contradictions. So generally, when you're finding a contradiction, you're in a negation introduction or a negation elimination subderivation, and you need a sentence and its negation. You want to look at lines that you already have in your derivation and try to derive the opposite of one of those. This is generally the most efficient way to do it. Um, However, there are cases where you can't do this. And if you know, I mean, if you figured out that the previous lines of your derivation are inconsistent, then sometimes there are going to be cases where you need to make an additional assumption to sort of roll out a contradiction. In those cases, then you can't just derive the opposite of a line that you already have. Sometimes you're going to need an additional assumption to get things moving. Another strategy is to let truth tables guide you. They can be really useful when you're working derivations. So you can use them to figure out when the lines in your derivation are inconsistent, so that you know that you can use negation introduction and negation elimination. Um, Another thing that they can do is they can tell you when a line would be entailed by previous lines in your derivation. So you can figure out whether a particular strategy would be a good one to take, right? Whether a particular goal sentence would be a good idea by looking at whether this line would be entailed by what you already have. Because if it's truth functionally entailed by previous lines, then it's derivable from those lines. And if it's not truth functionally entailed by previous lines, you can't derive it from those lines. You would have to find a new goal. We've seen an example of this, sort of, right? We were looking at whether a sentence letter was derivable from zero previous lines, which is, special case of that. The last strategy, this is the one that we haven't really talked about yet, is don't reinvent the wheel. I mean, watch for patterns that are familiar, for things that you have done before. And because if you've worked through something in a previous derivation, then and you come across what is essentially the same thing in a derivation that you're working on, well, you can adapt what you've done before to get you through this new one. This kind of thing will come up quite a bit. So if you keep track of the ways that you've done things before, this can save you a great deal of work and just make things a lot easier for you. Here's an example. Okay, so we'll do this example here. So we're going to show that this sentence is entailed by this set containing this one sentence. So I've already written out that sentence as the assumption at the top. This is our overall goal sentence. It is a conditional, so we will derive it by conditional introduction, and I've already set up the subderivation to do that, right? Starting with the antecedent and ending with the consequent. So the next thing that we would want would be to, this would be our next goal sentence down here, right? If W, then R. Um, but you could actually just look at this and notice. So we have if F, then not W, and we have F. That means that we can get not W, working top down here, right? From 1 and 2, conditional elimination. And so now we've got not W, and then we've got that up here, and then down here, right, as our goal sentence, we've got W implies R. And this is a lot like something that we've seen before, right? This is one of the paradoxes of material implication, right? We demonstrated this just for different sentence letters, right? If you have not A, then you can get if A, then B. So here, in order to go from not W to if W, then R, we're just going to go through exactly the same procedure that we did here. I mean, just look at this, look at how we did this, and we're just going to do exactly the same thing. So we will introduce a new subderivation where we assume W for conditional introduction, because that's what we did in the previous derivation. We're then going to introduce another one where we assume not R for negation elimination. Then looks like I need a few more rows here, at least that many. We're going to reiterate, because we can use the principle of explosion now. We have these inconsistent assumptions, so we can reiterate W from line 4 and not W from line 3. That is the contradiction that we need to end that subderivation. So we've proved R by 5 to 7, negation elimination. And yeah, and then we've then linked up, right, the W and R here. And this is exactly the same thing as we did here, just with different sentence letters and different line numbers. So pay attention to this sort of thing, right? When you use strategy in one derivation, you can make use of it again in another one. I mean, this derivation then just pretty much by just copying from a previous one that we've done, this one's basically finished. All we need to do at this point is just fill in the line numbers and draw in the scope lines.